So in today's class, we are going to see how to determine a substance undergoing reduction and a substance undergoing oxidation in a chemical reaction. Okay, firstly, let's look briefly at the definition of redox reaction in terms of oxidation number. Now, redox reactions is coined from the two words reduction and oxidation. Okay, the RED comes from reduction and then the OX comes from oxidation. So when you combine the two, you have a redox reaction. Okay, redox reaction in terms of oxidation number. Now for reduction, a substance has undergone or is said to have undergone reduction if the oxidation number decreases. So when you have a chemical reaction such as this, you have Fe3+, which accepts one electron to give you Fe2+. In terms of the oxidation number, when you look at this, the oxidation number here is 3, while at the product side it is 2+. Now, if you look at the oxidation number, it is reducing. So in that case, we say that ion 3+ has undergone reduction. Now, why for oxidation? A substance has undergone oxidation if the oxidation number increases. So in oxidation, the oxidation number tends to increase. For example, let's say you have X2-, okay, and then gives you X, okay, solid plus electron, 2 electron. Now if you look at this, the oxidation number of sulfur here is -2. Now while the oxidation number at the product side is 0, okay, is 0 because the oxidation number of any element in the free state is equal to 0. Now if you look at this, the oxidation number tends to go up because if you're moving from the negative side to the positive side, you will notice that means the number is going up. So sulfur in this case is undergoing oxidation. In case you are confused about the negative value, let's look at another example. Okay, another example is, let's say you have copper, okay, giving out copper forming copper 2+ by giving out 2 electrons. Now copper in this case, because it's in the free state, the oxidation number is 0, and in this state, in the ionic state, it is 2+ or +2. Now if you look at it, the oxidation number tends to increase. So at this point, we say copper is undergoing oxidation. So let's see how to determine if a reactant is undergoing reduction or oxidation in a balanced chemical equation. Now note, oxidation number of a molecule or atom in its free state is 0. And how do you identify these atoms or molecules in its free state in the chemical equation? Okay, simply by noting how free they are. If you look at a chemical equation, then you see chlorine not bonded with any other atom or ion. It means that it's in its free state. Another example is hydrogen. We have nitrogen gas, we have aluminium, copper, and iron. So all these atoms, when they are alone, okay, they are not bonded with any atom. It means they are in the free state. Automatically, the oxidation number becomes 0. Okay, it's different from, for example, let's say you have sodium chloride. This is chlorine. Now, because chlorine is bonded with sodium, it means that it is not in its free state. Okay, chlorine oxidation number is not going to be 0 here. Another example is, for example, if you have aluminium oxide, okay, aluminium here is not in its free state. Okay, if you see it like this in a chemical equation, it means the oxidation number is not 0. But however, whenever they are in the free state, their oxidation number is equal to 0. So let's take a look at this chemical equation and let's determine which molecule is undergoing reduction or oxidation. You have So we want to determine which of these reactants is undergoing oxidation and which is undergoing reduction. So how do we do this? The first thing you have to do is calculate the oxidation number of the sulfur here in the reactant and the sulfur here in the product side. Now for the reactants, let's look at sulfur. So we have 2H plus X. So we are calculating the oxidation number of sulfur. Hydrogen is 1 equal to 0. So this is 2 plus X equal to 0. If you make S over to the formula, this one goes here, becomes minus 2. So the oxidation number of sulfur here is minus 2. Now if you go to the product side, the oxidation number is 0 because sulfur is in a free state. Now if you ask yourself, is the oxidation number increasing or is it decreasing? Now, moving from minus 2 to 0, okay, you will see that the oxidation number is increasing, right? So it means that sulfur, this compound, is undergoing oxidation. Now let's look at chlorine. Now, in this case, at the reactants place, chlorine is in a free state, so the oxidation number is 0. Okay, for hydrogen chloride, at the product side, hydrogen chloride, we have, let's calculate the oxidation number of chlorine. We have H plus Cl. Hydrogen is 1 plus Cl equal to 0. So Cl is equals to minus 1. So the oxidation number of chlorine here is minus 1. Now if you look at this, the oxidation number is reducing from 0 to minus 1. Oxidation number is reducing, so because of that, we say it is undergoing reduction. So let's take a look at another example. Now we are going to determine which of these reactants is undergoing reduction or oxidation. Now, let's take a look at the oxidation number of iron at the reactant side and at the product side. Now, for iron, let's determine the oxidation number of iron at the reactant side. We have 2Fe plus 3 oxygen equal to 0. Okay, so for iron, we have 2Fe plus oxygen is minus 2. Equal to 0. So this becomes, so 3 times minus 2 will give us minus 6 equal to 0. So we have 2Fe equals to, we have plus 6. So divided by 2, this cancels this. This goes here, so we have plus 3. It means the oxidation number of iron here at the reactant side is plus 3. Now, while for the product side, it's quite easy because iron is at the free state, so it is 0. So if you look at this, okay, it means that the oxidation number is decreasing, so it is undergoing reduction. Now, I want you to understand this. If you're writing an exam and you don't want to waste your time, if you're asked to determine which of the molecules are undergoing reduction and which is undergoing oxidation, once you have gotten one of them undergoing reduction or oxidation, the other molecule would be undergoing the opposite. Like for this example, we have determined that iron is undergoing what? Reduction. So that means automatically carbon is undergoing oxidation. But let us calculate the difference in oxidation number to confirm. Now for carbon here, we have CO. So that we have C plus O equated to 0. So carbon plus oxygen is minus 2. So we have minus 2 equal to 0. So this becomes C minus 2 equal to 0. So if this minus 2 goes here, we have C equals to plus 2. So carbon here is plus 2 at the reactant side. Then at the product side, let's see the oxidation number. So carbon here, we have C plus 2 in brackets, oxygen equal to 0. So we have C Oxygen is minus 2. So this becomes C. Okay. Plus, and 2 times 2 will give us minus 4 equal to 0. So this becomes C minus 4 equal to 0. So therefore C, this one goes here, becomes equal to plus 4. So the oxidation number of carbon here is plus 4. So if you look at this, it means the oxidation number of carbon is increasing. So therefore we say that it is undergoing oxidation. Thank you very much.